Hello everyone, could you please confirm if you can hear me well and see my screen too?
Yeah, we can hear you well, Sarah. We can hear and see. Go ahead.
Okay, thank you. Uh, well, do you mind telling me the last topic where we have stopped the session? All right, everyone, let's get started. So the next topic is about standard input, standard output, and standard error. Okay, there are a lot of system variables in a Linux system, different types of system variables, I would say. And so standard input, output, and error are kind of special variables present in Linux system. Okay, or you can also consider them as a special representation of standard input, output, and standard error. Okay, so the corresponding numeric representation is 0, 1, and 2. So when I say standard input, so we usually use our keyboard in order to give input to the system. So you can consider that as standard input. Standard output is your screen command prompt where when you execute something you see some output on the screen, right? So that is your standard output. And standard error is where when you execute uh, a command which doesn't result out successfully, then you can consider that as standard output. So standard input is something that we are not going to implement now, because implement now in the sense everything that we give as input to the system is a standard input. Okay, so uh, when I say ls, so whatever output that you see on the screen is a standard output. Okay, and say for example I say something like this, and the output says no such file or directory. Okay, so that is called as a standard error. Okay, so it means that the file is not present and the system has thrown an error on the screen, which is called as the standard error. So standard output can be represented as 1, standard error can be represented as 2. So let us see how we can make use of the numeric representation of standard output and standard error. So when I do something like this, so what I'm doing here is the output of ls command is being redirected to a file called stdout. Okay, cat stdout will have the output of ls command. So I am the standard output to a file. Okay, let me give you a better example. We'll take any of the file here, say ls error.log. Okay, the output is successful. We have got a message. Now, in this output, we have two things. One is standard output, another part is standard error. Okay, now what I can do is, you see what happened now in the output. The same command previously has displayed both the outputs on the screen, whereas now it is redirecting 2. So 2 is being redirected to /dev/null. So standard error. So as I said, standard output is 1, standard error is 2. 2 is being redirected to a different file. Clear? What we can also do is, this. So the output of this command up to here, I have redirected to a test file. Okay. So output of this command, in the sense, only the standard output goes to this file. And the standard error part which is there, what it did is 2 redirecting to &1. That means redirect 2 to the same place where 1 is redirected. So 2 is standard error. I have redirected 2 to the same place where 1 is redirected, which is test file. Now if you check the test file, both the error messages are present. So this concept, okay, of redirecting standard output and standard error is important. And in the previous example, I have used a file called devnull. Devnull is like a black box. So whatever you redirect to dev null uh, won't exist in the system. It gets deleted in the system. Anything. Say for example, I am redirecting an entire file. Take any file like Anaconda. It's a big file, you know. Okay. Cat anaconda.clg redirecting to /dev cat/dev. So whatever you redirect to dev won't exist in the system. Okay, so this is all about standard output, standard input, standard error. Clear? Okay, so with this, I think we are pretty much done with the concepts of the first module. Just to revise, I would like to show you the screen. I hope you all remember the different run levels, right? So run level, this is run level 3. If it is a CentOS 6, we say we use the init command in order to switch between the run levels. Whereas if it is CentOS 7, we can use init command also. But so this is the default process. So systemctl set-default in order to set the default run level. So in CentOS 6, we were using init tab file in order to set the default run level, whereas in CentOS 7 we use this process. Okay, so systemctl set-default. Whereas if you want to check systemctl get-default, get-default will display the run level that is also set. If you want to set, you can do set-default, and this supports the tab completion feature. So you can do multi-user. You can simply type a few characters of this word, and pressing tab will display all the available options for you, using which you can set a graphical target or a multi-user target, which is similar to a graphical mode and a non-graphical mode. Okay. Okay. Now give me a second. I will open another presentation. So with this, we are done with the first presentation module topics.
I have a question here.
Sure.
So, for example, we set the display option, right? It's general to the setting up display option, like graphically launching an installation, or basically instead of running on the command line, we install it in a graphical mode. That we use that export display option and we set the external display, right? Why is this exactly used for?
I'm not very clear about your question, but let me answer in my way. So this is mainly used in order to start your system either in a graphical mode or in a non-graphical mode. So if you take this example, here I have started the system in a non-graphical mode. So non-graphical mode, previously it was run level 3. It is also called as a multi-user target from CentOS 7. Whereas the graphical mode is so it is called as a graphical dot target in CentOS 7. So set-default, what it does is, say for example you have shut down the system and you have started. So when you are starting your system after a shutdown, so the system automatically starts in a default mode. So set-default will reset the default mode to your system to a graphical mode. Similarly, here this is a non-graphical mode. So we have seen the init command using which we switch between different modes. So that is say init space 5. So we switch to ready. But after shutdown, if you start your system, there will be one default mode using which the system starts. In order to set that mode, we use these two commands. So Does that answer your question?
So basically, it's a OS level setting how you can view the screen, right? Graphical will
Correct.
show you the graphical view, and other one is more of the
Correct.
regular command level.
Yes, correct.
Okay, thank you. Cleared my question. Thank you.
Oh, okay. So the second module that we'll start is more about package management. So today we'll see how to install packages in a Linux system, the different ways of package installation, and how to configure a local repository, and also some information about various network tools in a Linux system. So I hope you so when I say packages, that means softwares. Okay, so in Windows you install different types of softwares, right? So similarly, in a Linux system, with respect to the different types of features that you are expecting, you need to install the corresponding software. So softwares or tools, what you say in Windows, so they are called as packages in a Linux system. Okay, and configuring a local repository is similar to configuring. I hope you understood the general meaning of the word repository. Okay, it's like, okay, take this example. It's a server site where you can see lot of you can see all the CentOS packages, RPM packages available, right? And I also mentioned that this kind of websites are available at every location. So wherever you are around the globe, so there will be a nearest place, and there will be a corresponding website from where you can download. So that is a repository. A repository is like kind of a source that which is nearest to you, that contains all the packages. So in this module we'll see how to configure a local repository. A local repository is like a source of all the RPM packages which are present in your system. So wherever you configure it in your system, you will be configuring a local repository. A real-time example on how we can make use of a local repository is, say for example, you are a startup organization, okay, and you don't expect all your employees to keep downloading the same piece of software that you use, like uh, say kind of Java or Oracle, okay, which is 100 MB, 100 MB in size. So if 10 employees download it, so it's like 10 times the same piece of software is being downloaded from the internet. So it's a waste of bandwidth. Rather, what you say is you download that software, okay, and keep it in a local repository. Local repository means in your private network, and all the users will try to copy that software from the local repository. So this concept basically enables you to reduce the amount of downloads that people are doing, okay, and you can also impose kind of restrictions on what they can download. So it is like you can set up some standards, like rather than people are not allowed to download on their own, so you are supposed to use all the softwares that the organization provides in the local repository. So you can also set up such kind of standards. Okay, so that is why we'll see how to configure a local repository and the different ways of configuring the local repository. Okay, so let's get started. So as I've said, packages in a Linux system, they represent the softwares. Okay, a package contains, not sure if you have observed the contents of a software package before, but here in a Linux system we'll review all the contents. That means a package basically contains uh, some binaries. So when I say binaries, that means the Linux commands that we use. Okay, so when you install a Java package, you get the corresponding binaries like Java, JavaC, etc. Okay, I hope you are clear with the binaries topic now. Similarly, we have a lot of commands. I use the same word for a lot of commands in a Linux system. So binaries are like commands. So a package basically contains these commands. It also contains the corresponding library files, and it also contains corresponding configuration files. So you have seen me configuring, for example, like the network related service, right? FCFG-ETH0. Similarly, every service, so a package basically provides you some kind of service, okay, and corresponding to that service there will be some configuration file associated where you make changes regarding how the service should work. Okay, so you may find configuration files, you may find library files, you may find the binaries, and in Linux system for every command there will be man pages associated. So the package may also contain man pages of that particular binaries that the package provides. Okay, so this is uh, a just simple overview of what the package is all about. Clear? So there can be additional files, okay, apart from the config, library, binary, and man pages. So you should, I will give you examples on how to open a package, how to check the contents of the package. So as you keep trying this on a few packages, then you will be clear about the contents of the package. So before moving on to the packages topic, here is a, I think we have already covered it, how to set up host name in Linux system. You can use the command called hostname. Okay, hostname space whatever name you give, it will save that as the host name, but it is a temporary change. Okay, the other way is hostname ctl space set hyphen hostname, and then you have to provide the hostname. So this is, as you can see, hostname hyphen ctl. This is a syntax that is followed in CentOS 7. Okay, till CentOS 6 we don't have this command. Till CentOS 6, what we do is we update a file called etc hosts, hosts. Okay, so inside etc hosts, as you can see on my screen, so I have included the mappings of IP address and the corresponding host name. So this is what we use it to till CentOS 6, but from CentOS 7 it is this file, and it is this command using which we configure the host name permanently. Clear? Similarly, okay, 1 second. Okay, so we have a few commands. Let's review the commands and then we'll proceed to the packages topic. So the next one is how to configure your IP address. So this is something that we have already seen in the previous sessions. So you open the network configuration file and you configure your IP address, your static IP, and corresponding to the static IP, the important other important features are you need to set up the boot proto as static. Okay, if you set it as dynamic, that is DHCP, then it will try to fetch the IP address from the local DHCP server. Okay, then so one is the command line way, so that is important. We have reviewed that. Another way is the graphical way or using the tool. Okay, so tool is something which you can use even in a non-graphical mode. So NMTUI will open that tool for you. Okay, so as you can see on my screen, it gives a set of options. So one is to edit the connection network related settings. So apart from creating a setting which is related to the network, you can also activate, you should also activate the connection. Remember, the first time you complete the installation process and start your system, your network adapter will be down. So you need to manually start your network adapter, and in this slide, on boot is equal to S. That means we need to change this option. By default, it would be on boot is equal to no. When you make on boot is equal to yes, your adapter service would also be up and running when you start your system. You should be ready to communicate with other systems in the network. If you run if config, you will see an IP address. Otherwise, if on boot is equal to no, it will not display those settings for you. You have to manually start the network service, then you will see all these changes. Okay, so that is a temporary change. If you want to make it permanent, open this configuration file and change on boot is equal to yes. Okay, going forward it will start automatically. Similarly, here you need to do activate a connection. That's what it means. Okay, so once you activate it, it will get activated. You also have an option to set up the host name. So this is your adapter file. Okay, you need to use tab in order to switch between the options that you can see here. Tab and upward downward arrows would help you to switch among the options. So again, here you can see it is the same set of options. So profile name, device are something which are already present. You need to just update the IP address, corresponding subnet, and here it shows for 1.1 it is 32, which is wrong. It should be 24. Then gateway is 1.1, DNS server is 1.1. That's it. These are the three inputs that you have to give. So that will update the network config file. And then when you activate it, you should be able to see the IP address when you run if config command. The next topic is on how to switch between the users. So switch user is a command that I have used multiple times. If you want to switch from one user account to another user account, we use su command. Okay, I hope you're clear about su and su space hyphen. When switching between the users, okay, say before the switch you are present under a temp folder. Okay, if you use su space some user, then you will switch, but the folder would remain the same. But if you use su space hyphen, okay, space some user, then you will end up in that user's home directory. Okay, so hyphen always ensures that you land up in the home directory of the new user. Who am I? I'm the root. I'm in the root folder. I switch it to user Saran. I'm in same root folder. Okay, again. That's it. Okay, so this is how we switch between the user accounts. So then comes a command called sudo. Sudo means only, I hope you clear that it is only the root user who has all kinds of privileges in a Linux system. Non-root users are restricted to their home directory, so they cannot open or they cannot modify the configuration files. They cannot restart or stop the services, all network related other services which are there. A non-root user cannot modify those changes in the system. A non-root user cannot install packages in the system. Okay, so it is like uh, only in your home directory as a non-root user, only in your home directory you can create files and you can access those files. So you're restricted to your home directory. But as a root user, you can do anything in your system. In a real-time scenario, we cannot rely on the root account all the time. Okay, so there will be multiple admin users, administrators present. Okay, who will be handling different types of things. For example, you might have an admin who completely takes care of adding patches to a Linux system, installing patches. Okay, so all patch management, package management. Similarly, there can be a different user who is responsible for the entire user administration, creating users, deleting users, creating groups and deleting them. Okay, so like that, there are different types of users present. So we need to give admin privileges to all these users. We cannot simply rely on the root account all the time. So the process in order to grant admin privileges to these users is sudo command. So using sudo we can grant the access. So using sudo means there is a file called uh, sudoers. Okay, etc sudoers. So in order to edit this file, we use vi sudo. So this is the way you have to edit the file. So vi sudo will open etc sudoers file in a editor. Okay, once you open this file, you go for the location called this one, root all. So it is like all types of groups and all types of permissions are granted for the root user. Okay, so what you can do is you can add the user at the bottom next to the root user. Just copy paste this line, replace root user with user called Saran, and then save and quit. Now I'm going to switch as Saran. Okay, we'll take one example where you don't see the output. If I run the same command, I can see the output. Okay, now if I want the user Saran to have admin privileges, I have to update that file. So there you have seen that I have already updated. So once I update it, I should say that the user Saran has sudo access. That means whatever command that I want to execute, I have to use. So not whatever command, but the admin related commands that I use. Before those commands, I have to use the word sudo. When I use it, it will ask me to confirm the password again. Then it will list, okay, taking another user called Ramesh. Okay, I have exited. This user is not part of the sudo list. So fdisk-l will not give any output. Say I use So it gives these warnings just to make sure that you are not performing any wrong command. You're not implementing any inappropriate command in the system. So I've given the password and it says that this user is not part of the sudoers file, and this incident will be reported. Okay, so non-root users should have the sudo access in the system in order to execute admin related commands. Clear? So there are two different ways. There is a group called wheel. So you can add this user Ramesh to this group. Okay, well, we haven't covered user administration yet, then I will explain this again. So there is this file called etc group which contains information about all the groups present in the system. Okay, so you have to add the user, you have to make this user part of a group called wheel, then automatically, so that is the alternative way. Okay, then also the user will get all the admin privileges in the system. Okay, so this is all about sudo access. Well, some more commands on the screen which are specific to CentOS 7 or Red Hat 7. So far I have only mentioned about init space 6 to restart your services. But okay, so seems there is a small transient issue with the network. Okay, I hope you can hear me now. Okay, so here, so using systemctl, we can reboot the system, we can suspend the existing session, we can also restart the system. So instead of init space 6 or init space 0, there are a lot of additional options that are available with CentOS 7 or Red Hat 7. Okay, so remember systemctl first. Systemctl is important. So using systemctl will be systemctl uh, start some service name. Okay, so that is how we have been using. We will be using the similar format throughout this course, and the same format is also used to start, stop, and restart your services. Okay, now it is about RPM package manager.
Saran, can
So
you go back to the previous slide?
yeah,
What is the difference between suspend and hibernate?
in Windows also you would get to see the hibernate mode. So hibernate mode is where your system would stop making use of, it will stop taking the power. So whatever session is, it will just try to, it's
The
like
slumber?
it's kind of a sleep mode where
Okay.
it will not make use of any of the system resources.
Got it. Like when the power drains, automatically system gets stopped, and when it starts, it go back to the same phase.
No,
That's the idea.
no, you can also consider it this way. Uh, whatever is the current session, all right? So current state of my system. So that state will be stored uh, in the memory, okay? And the system will stop making use of it will stop making use of the power. The moment you again start your system, your state which is there, it will be restored. So it is not, so I have opened a lot of files on my desktop. If I put my system in hibernate mode, the system will not close any of these applications. Okay, the moment I start, it will keep all these applications open. So it is like restoring the state of the system. Okay. So
Sure.
just
Great.
try these options once. So that is a better way of getting a feel of what these are, each of these options. Just try it once and let me know if you still have any questions. I will explain it again. Okay, so the next one is RPM package manager. So in Red Hat, okay, so we have one question here. Will sudo reboot work instead of systemctl command? Okay, let me take the prompt. So as a non-root user, fdisk-l is the command to display the partitions or the drives which are present in a Linux system. Clear? Similarly, uh, systemctl, for example, reboot is the command uh, that helps in rebooting the system. So this is CentOS 6, okay? But don't mind about the error. So if I'm allowed to run these two commands, then it would have implemented these two commands. Since I don't have root access, but now I have been given root access, I need to implement by saying sudo fdisk-l. Similarly, I should say sudo systemctl reboot. So the commands would remain the same. There is no change in the commands. So sudo is like a special pass in your hand. Okay. So you need to show this pass and give your password again in order to execute those commands. Clear? Sudo is not a replacement for the existing command. In order to execute an admin related, yeah, please go ahead. Since someone has a question.
Some other student join. You go ahead, Sarah. You go ahead.
Okay, so what I was saying is sudo is not a replacement for another command. You have to use sudo along with the command. Okay, provided the command is admin related command, and if you execute that command, if the system says you don't have privileges, okay, then you have to run it as a sudo user. How you run it? You use sudo along with the command. Okay, so coming to RPM package manager. Okay, so there is another. So one of the participants mentioned that for RHEL that command will work as per my experience. Okay, see, I have just randomly ran these two. Okay, as you can see, fdskyfinal didn't work for non-root user. So systemctl reboot option might work. My intention is to tell you that, so if you run a command, if it says that you don't have privileges, or if it shows you no output on the screen, then you have to use sudo command. Okay, so the example might not be appropriate, but my intention is to say that for sudo access, so this is how it works. Okay. Okay, so next about RPM package manager. So RPM package manager, which is a Red Hat package manager, all the packages in Red Hat or CentOS will have an extension of .rpm. So package name, version name, whether it is a major version or a minor version, and then it will have information about the architecture. Let me see if I have an example for you. Okay, let me open, or maybe here I have it already. So you can see here, right? So these are all kind of packages available. So the package name, some of the version, and then you have rel7, el7, x86_64 is which represents 64-bit architecture. Okay, your system will be either 32-bit or 64-bit, right? So this is the representation of 64-bit architecture. If it is 32-bit, you might see i686 or i386, I think, something like that. You would see in the extension. So this is the package, and this package is already installed in the system. That's why you don't see .rpm as an extension. Okay, prior to the installation, if you download a package, it will be in a similar format with .rpm. So RPM stands for Red Hat Package Manager. Okay, so all the Red Hat related packages are available with .rpm extension. In fact, RPM is a command using which we install packages in a Linux system. Linux system, mainly Red Hat or CentOS. So if I have, let me download and copy a package. Okay, so as I've said, RPM is the command using which we can install, remove, we can query the packages. That means check whether a package is installed or not, and we can also upgrade the packages. Okay, and we can also verify a lot of information about those RPM packages prior to the installation and also post the installation process. Quickly, to show you the corresponding tool using which you can do the same. Okay, so if you are in graphical mode, you can go to this location, application, system tools and software, where you can choose the packages and install those packages in your system. Okay, this is just for your reference, but we will never be making use of this tool. We will only be installing the packages in a command line mode. Okay, but you can try this option. I'm just giving you where it is and how to make use of it. So this is pretty much user friendly. You can choose the package and perform the appropriate, give the appropriate instruction to install, remove or check the dependencies for that package. Okay, so coming to the command prompt way. Okay, RPM is the command using which we can do all these kinds of things. So first of all, starting with RPM -QA. QA means Q is to query, A is to query all the packages that are installed in my system. So add is a command that we have already covered. So if I do wc-l, I will know how many packages are installed in my system. 319. Clear? So if I ask Q to check whether a package is installed or not, you remember the grep command that we have used before? So the same thing you will be using rpm-qa grep take cron. All these are the packages related to cron, HTTP. I think there is no package starting with HTTP, it is Apache. Well, even that package is not available in the system. So this is how you will be checking whether packages are installed or not in your system. Okay, so like this, there are a lot of commands that are associated with the RPM command itself. If you look into the man page for RPM, you can see all those information. So here the command is checking for the DHCP service. RPM-QI. So Q is to query and I is to get the information regarding a package that starts with grep. Okay. Grep is a command that we use. Grep is a tool or a utility using which we can process the data set for strings inside files. Here in this example, so we are trying to get the package that provides the grep command. Okay, so grep with the name of grep, you can see the package name here. So this is the package that provides the utility called as grep, and you can also see there's a bunch of information available related to the grep command. So this is how you can check information about any of the commands that are installed in a Linux system. Another way is you remember this command where is ls. So in the beginning, when explaining about how binaries work in a Linux system, I have used this command, where is ls, where is grep. So it will tell you where the binary is installed. Okay, so here it says user bin ls. So this is the path. Now say if I ask you this question, there is a command called mkdir. Okay, what is the package that provides me this command? Say if I ask you this question, how do you figure out which package provides mkdir? It need not have to be uh, a package that starts with mkdir. Okay, so just because grep command has been provided by a package starting with grep, every command it is not similar to all the commands. It doesn't happen that way. So the example that you can see on the screen is the best example for that. So user bin ls is the path of ls. You can do rpm-qf and give the entire path that will tell you the package that has provided the ls command. Clear? So this is how you can identify the package. It is like doing a reverse check on. So usually if we have the package, we get the information about the contents of the package. But if I have one element of a package, how do I figure out which package has provided that element? So this is how you can check it.
Karan, can you
Yeah,
expand? You tell on QF. I know QI information, QA list, QF in the above screen.
QF means, yeah, it provides the information about the package.
The
or you want
location
to
of the package,
know?
right? F
No,
is
no, no.
location
It
of the package.
is the name of the package that has provided the binary. That means by installing this package, I have got this binary.
No, I understand. I got it. The core utils has a bundle of packages. From that's where I got this ls. I understand that.
Yeah.
Why you are using qf? Because it's a different name or a
All
yeah
these are
Q.
arguments. First of all, Q itself represents query.
Very
So RPM maintains, it is kind of a database that RPM maintains. It maintains the information about all these packages that are installed in the system. So what is the package that is installed? What are all the binaries that the package has provided? So when you do -q, it will query that database. So with A, it will check all the packages. I, it will only pull the information out of the database and display that for you. Similarly, F, with F, it will tell you what is the actual package that contains this binary.
got it. Now got it. Thank you. Thank you.
Perfect. So we have other arguments. So I have only mentioned some of the important ones. So whatever I have mentioned, I would definitely suggest that you practice all these arguments. In fact, if you look into the man page of RPM, there would be a lot more arguments over there, but at least try to remember the arguments that are mentioned on the screen. Okay, so next is RPM-QL. So QL is used where if you, so previously we checked it for ls, right? So we have got to know the package. If I say I want to know the package that has provided ls and also all the contents of the package. So what else is the package providing me? So that is where QL comes into the picture. Here you can see. So as I've said, a package contains binaries, uh, man pages, blah blah blah. Here you can see all the contents of the package that contains quota binary. So it has quota. All these are sbin, wherever bin and sbin is. These are all binaries. And wherever user share doc starts, these are the documents. User share man, these are all the man pages corresponding to the commands which are here. So that is the importance of QL.
Can you try ls in the same way?
Yeah.
RPM space minus QL space ls. Okay, any other example, Sharon, on that same?
Uh, okay, so it is the ls command is provided by the package called core utils, starting with core utils. So by giving the core utils word, it will display
What are
all
all
the
the
contents,
activities, what it can do?
yeah, all the binaries which are part of that package. So
Oh,
previously quota is the word that start the package name starts with that. Okay.
got it. Thank you.
Okay. So just give me 1 second. Let me. So you remember this location? This location contains all the packages, different versions of your operating system, etc. So this packages folder contains all the packages that are related to your operating system. So I'm just taking the same example here, telnet-0.17. So this version, okay, or maybe as you can see from this location, I'm going to download this package, and from Windows to Linux, I'm going to copy this particular package. If you want to know the software using which we can copy, so one I told you the client tool called as Putty, using which you can connect, right? So this is my system, if config, and so this is my Putty, okay, 192.168.1.125. So this is an open source tool. So if you are in a corporate environment, you might they might be using some commercial tools or open source tools. So where the concept is the same. So when you have a physical Linux machine running somewhere, you have the connectivity. When you have a tool, using this tool, you will connect to the client. Okay. So now this Linux machine is present uh, on my laptop, so I'm able to open it and perform all kinds of activities on the machine. Say if I tell you that this is the IP address of Linux machine which is present remotely, okay, connect to Linux system, these are the credentials. How will you connect? So now using this client tool, you have to connect to the remote Linux machine. Okay, I've given the IP address, I've given the username, I've given the password. So it has opened an instance of the Linux system here. Again, I can start working on this particular instance. So another comparison would be here in this is a virtual box, right, that I've started. I cannot copy paste. So for example, this Windows package, right, Control C, I've copied. I cannot paste it here. If I click, the arrow goes inside. Again, I have to right click and bring it back. So copy paste doesn't work. So at least for that case, here it works. You can use the putty. So this is to interact, okay. And if you want to copy, say you have downloaded a package and you want to copy it to your Linux system, for that we use a tool called WinSCP. So using this tool, uh, concept again is the same. Okay, you mention the host name, username, password. Okay, let me show this. So what it is doing is connecting to the Linux machine. So one side it will provide the Windows environment, and the other side it will provide the Linux environment. You can see that, right? So what I can do now is simply drag and drop. Then that file will get copied from a Windows to Linux system. Similarly, vice versa. So this is how you can uh, copy files from one instance from Windows to Linux system. So WinSCP is one of the tool that is available, which is open source. So now this RPM package, so I have to copy it from Windows to Linux, and once I copy, I have to use that package in order to perform the installation. So how I do the installation? is, first of all, before installing, usually we check whether the package is installed or not, whether the package that we have installed is latest or not. So now that we have Red Hat 6, before Red Hat 7 gets released, so there can be different versions of the package available. In case if there are any bugs associated, they might release different versions of the telnet package. So you can compare the versions. If it is already if it is not installed, then we have to install it. And this slide shows how to perform the installation. This one. So in this slide, along with RPM, I have mentioned hyphen IVH. V and H are not mandatory. Hyphen I means to install the package. V is to display the verbose like information, and H is to print the hashes. Hashes, it's like, you will get that feel, okay, the installation is in progress, 50% is completed or 100%. So the hashes that are printed, so, so that's what VH is about. Rather, you can simply do RPM space hyphen V. It will not print anything. It will simply install and display that message. You will get the prompt back. Okay, that is simplest way. So this is how we install the packages. Say for example, the package is already installed, but it is not the latest version. Okay, you have whatever you downloaded is latest. In that case, instead of I, we use hyphen U, capital U. Again, VH is common. If you want, use it. Otherwise, it's optional. Hyphen capital U, what it will do? It will upgrade the package from I to capital U. Clear? So this is how we install and upgrade the packages. Well, this is one way of doing the installation process. Usually, so far you have seen that in order to install the packages, we have to download it, copy it to the Linux machine, and install the package. The example that I have showed you here, Telnet. So this package doesn't have dependencies. Remember the installation process that we have seen in the first class, where before a package is getting installed, so we have chosen all the necessary packages, then it has started pulling out all the dependencies. It showed that message on the screen. Similarly, when installing a package, there is a possibility that it has dependencies. That means other packages should be installed in the system before this package is installed. Telnet doesn't have dependencies, so we have at least whatever uh, packages that we have already installed. They doesn't so Telnet doesn't have any additional requirements. Mostly, it will install or the moment you issue the command. But this doesn't happen with all the packages. So when you install an RPM package, there is a possibility that it might throw an error saying this package needs this package to be installed. These are the dependencies. Then you have to download those three packages, install them first, okay, and then install the actual package. And if you might have this question in mind, what if those packages again have dependencies? Obviously, you have to download those packages also. So there is a lot of manual work associated when installing packages with the RPM command. You need to get all the packages associated. You need to download them, install one after the another, then install the actual package in the system. Okay. Well, RPM command mostly is preferred for vendor packages. That means say Java. Okay, so Java package, when you download the Java package, okay, so it may not require additional dependencies in your system, or some software related package which is available in an RPM format. So if there are any dependencies, it will clearly tell you in their website itself. Well, mostly they may not require dependencies. Okay, so those packages have to be installed using RPM command. You have to download them and use it in your system. Well, nowadays, in fact, they are also providing an alternative way in order to install those packages. So I'll explain that. So other than RPM, we also have another way of installing the packages. So, that is called as YUM, called Yellow Dog Update Modifier. So that doesn't matter what YUM uh, full form is. Okay. Uh, let's just give me 1 second. I'm going to keep you on mute. Just 1 minute. Okay. So, so YUM is the most preferred way to install software in the system, to install packages in the system. Okay. So the advantage of using YUM command is YUM will automatically pull the packages from the internet. So from the internet means from the repositories, YUM will pull the packages and it will automatically download the dependencies and install them in the system. So that is the advantage of YUM command. Okay. So we'll see some examples of how to use YUM command. So first of all, so how YUM works is important. So how YUM gets to know where packages are located. So that is the next question, right? When I say YUM install the packages automatically from the internet. So where does YUM get this information? You might relate this to other softwares that you install in Windows as well. So how does YUM get to know where these packages are located? There is a configuration file called etcyum.conf. Okay, and there are also repository configuration files under etc yum.repos.d. So here I opened one of the repository file for YUM. So here if you observe, there is something called mirror list is equal to mirror list.centos.org. Some variables are mentioned. You see this URL? It is the same. So this file contains the website where YUM has to go and search for the packages. Okay, so in order to install packages using YUM command, it is mandatory YUM will go download the packages as well as the dependency packages, and then it will install them in your system. Now we'll take the same command. So telnet is not installed. Clearing the screen. How you install using YUM? You simply tell YUM to install a package. So YUM install telnet. So we need not have to provide any other details. YUM will go and install the package for you. Well, before installing the package, it will ask you to give a confirmation. Are you okay if I install this package? Yes. Well, here, so installation is done. If you observe, it says finished dependency resolution. So this package doesn't have any dependencies. So that's why it has only downloaded that package. So this is how is very simple. Okay, yum it will do that for you. You can do yum remove, same way install yum remove. And important use case of yum is yum provides. Yum provides or yum what provides. Okay. Uh, say grep. So you know a command, okay, and you did yum install that command, and yum identify the package, and it says package not found. That provides the command, okay, yum provides grep. So so you might say that we can also use RPM command in order to check applicable post the installation of the package. So RPM doesn't go look into the internet and tell you what is the source package. Only if you install that package, then you can get it from the RPM. But yum will tell you the name of the package that you have to install in called as grep. You would need this command yum provides, or you can also say yum what provides, no space, yum space what provides space, whatever command that you want to check. So here it says this is the package. Well, since the names are the same, we can simply say yum install grep. That should work. So remember, while talking about the objectives of today's session, I said we'll see how to create local repository. Now yum is going and it is connecting to uh, a website and it is downloading the packages. Now if you have a question, what if I don't have internet connectivity but still I want to download packages using yum command? Well, if you have uh, a DVD, operating system DVD will have all the packages, right? So all these packages, say for example you have copied all these packages uh, to a folder which is present in your network. Okay, so as long as you are connected to a small network, you can create a shared folder across the network. You can copy your packages to the shared folder and you can use yum in order to install the packages from the shared folder. So the shared folder will have packages copied from your DVD. So that shared folder which is present locally in your network, it acts as a local repository. So instead of allowing people to install packages, say let us take this example. Previously I said software packages, rather than allowing people to download all these packages, what you can do is you can create a local repository, keep all the packages. So with respect to Linux system, all packages can be copied to the directory. If you are downloading a vendor package, you can again copy that to the local repository. Like that, everything can be copied over there and let the users download or copy these packages from the local repository. So that is where it is mainly used. So we'll get to that. Okay, and let's see what other arguments we have Okay, so the next one. So with yum, you can refer to the man page and check for other arguments. The important ones are install, remove, okay, and also to check the package name. So now if you want to create a local repository, okay, so you need to install a package first, okay. So that package will help you in order to build the local repository. So creation, installing that package is step one. Copying the contents of your DVD is step two, and creating a yum repository file is step three. So you need to follow three steps. Okay, I repeat, you have to create a local folder and copy all the contents of the DVD. So this folder can be anywhere part of your local network. Number two, you need to download a package that would help you to build the repository. The third one is configuring a yum repository file. You need to create a repository file and mention details in it. So you can see on my screen. So this is how a simple repository file would look like. So if you want, you can also take the existing repository files for reference. Okay. So before configuring a local repository, we will move all the existing files which are there in our local repository to a different location. Otherwise, yum will try to get information from those files. So our intention is only to set up a local repository and make sure that yum goes and searches for the packages from that repository only, right? Okay. So we will see how to create that repository now. As I've said, before creating the repository, we need to move all the files which are part of that repository to a different location. Remember star? We have used star that matches everything, and I'm moving them. Let me create a directory under root. There is nothing now. Okay, and I'm just creating a test report. Deleted everything. I can name it anything. No restrictions. I'm disabling the GPG check. That is necessary only for vendor packages. So this is a HTTP link. Have you ever tried opening a local folder? I mean, so in Windows, right? If I click on a folder, there I can see the path is saying that C:// that path would be there, right? Similarly, in Linux, if you try opening a directory like this in a graphical mode, it starts in this format: file:// then start the path starting from the root folder. Okay, so say I created a repo, and then you can have something called enabled. So enabled means you can have a repository file, but still you can disable it. Okay, so previous repository files which are there, there are too many files inside. So rather than disabling all, I've just simply moved them. Okay, so you can also have an enabled or disabled flag. So these are the minimum things that are necessary. So GPG check is something that I've not mentioned, because so GPG check basically is applicable for vendor packages. So we need that check to test that this is the actual source package. Okay.
Sharon, do we have requirement like this? Can I have check our internal repository? If I don't find it, go to internet and download it. Will
Well,
there be
that's
a
a good
requirement like that?
question. Uh, See, you can have both the repositories included.
Mm-hmm.
Can you put on mute? I'm getting that echo voice. Okay. So what I'm saying is, uh, you can have the local repository path as well as connection, as well as another repository file that points to the internet. You can have both in the repository directory, but I'm not sure whether it will follow that order or not. I have never tried that, but I will check and let you know. So what you can do is you can have in the order, right? So yum basically goes and looks inside the repository file. Take the same example. Okay, so let us assume that it will check uh, from the beginning of the file. So initially you put your local repository information, and below this we can also put another repository information. So there you put information about the internet. So initially it will check local repository. If it is not present, then it will go to the second repository link and search from the internet. So that is the solution I have now, because I'm very sure that it follows this order. What you can try is just follow this, check. So after we complete the installation using local repository, copy the same set of lines, create another repository location, point it to the internet, and then whatever package that you want to install, remove that package, make sure that it is not there in local repository. Okay, then do yum install. So what it should do is yum will search the local repository. So you can see that information on the screen itself. It says that searching this particular repository. So if it is local, it says I'm searching local repository. So it will say package not found. Searching another repository. So that's where the second repository that you mentioned will come into the picture. So so I'm very sure that this order would do the job. So whatever that you have requested for, just try it. If it doesn't work, maybe then I will check.
Agreed. Agreed.
Okay. Okay, so you can see here, right? I have created a similar format. So the name of the repository and name, that doesn't matter. So I'll quickly make those changes. So I'm not going to keep the GPG check also. It is optional. So in case you want to keep it,
What does that particular does?
sorry?
What does the GPG check does?
Yeah. So what, can you mute it? So RPM packages are provided by For example, Red Hat provides RPM packages. Okay, so there is a possibility that people, they tweak those packages and make it available in the internet. Maybe they can add viruses, etc. Okay, so as a part of installing the package, you might end up installing the viruses. But if you have the DVD which is provided, for example, the CentOS ISO or the DVD from Red Hat, you are very sure that it will have the packages which came directly from Red Hat only. So you perform the installation. But if you are not sure, okay, you need some mechanism to cross check whether they are actually from Red Hat or not. So this GPG key which is there, okay, so it helps in doing such kind of checks. So if you provide the GPG key file, okay, so the GPG key file, there would be some kind of uh, algorithm associated that will check, the corresponding key as a part of the package. In case if you have modified the package, so that key would change. So the system would say that this is not the original package that Red Hat has created. So that is what the concept of GPG key is all about. Okay. So since we are going to copy the packages from the DVD, we don't need the GPG check. Whereas for third-party packages, third-party vendor packages and all, they will provide the GPG check. So you can check it and then copy the package in your system.
Great.
Well, this folder is something that is totally up to you. You can either have repo or under repo, you can create anything. Okay. So creating the repository file is done. The next one is to install the package. The name of the package is create repo. Create repo is already installed in the system. Okay. So first of all, now the next step is we have to create the repo directory is already present. Okay. I will create this folder. We'll make use of this folder. Here. Now you have to go to repo Red Hat and use the command called create repo dot enter. So create repository, again what it will do, it will create some files. You can assume that they are kind of uh, a database. Okay, so they maintain all the information about what packages you are downloading using yum. Okay, similar to RPM, so it maintains its own files which contain all the information about the packages. So installing the package and local setup is completed. Now we need to copy all the packages from the DVD. I have copied one package. So I'm going to create a repository, keep only one package inside it, because the process of uh, building information. So after you copy the packages, okay, and when you try to install it for the first time, what it will do is it will take a lot of time to build all the information around these packages inside its database. So that process will take too long. So we'll use one package. We'll build the database using one package, and we'll install one package. Again, if so, when you are testing it, maybe you can copy more than one package. Okay. Now, if you remember, we have already installed Telnet, and I have Telnet package only for my example, so I'm uninstalling it so that I can install it now from the local repository. And okay, so I used create repo space dot because I'm already inside the directory, so I used create repo dot. Whereas if you're running the same command from outside, just mention -d, that is the name of the directory. Clear? And I have copied the package also. So yum clean all will clean the yum cache. Okay, done. Now yum install telnet. So first of all, at least you can see that it has considered the local repository because I have mentioned my name as the local repo file. Okay. I think I have missed some step here. Let me quickly cross check. So we have created the yum config file. Okay, let me tell you, there is a small change in the order I have implemented these steps. So that's why it didn't install. So what I mean to say is, we have created this directory. Let me do this. So Red Hat, let's create Fedora. Okay, after creating the directory, what I did previously was I went to this directory and I ran dot. Okay, but before running this itself, if we copy the package, I mean all the packages which are part of your DVD, okay, then you run create repo. dot. So as a part of building the database, it will pull all this package information and build your database. Okay. Then you run yum clean all. So this step, create report space dot current directory. This is going to take long time, because if you have all the packages copied, there will be some 4,000 packages. It will take some time to build this database with all that information. So once this is done, you can update this file. So repo fedora, then do yum clean all, yum install. That will install the package. So that's why I didn't install for the first time. Now it has pulled the package from the local repository. So this is something which you can check here. Clear? So steps are as it is the same, but copy the packages, then build the database in that, build the repository. Now this process of creating local repository which is there, it can be done in multiple ways. So now I have given the path of a local path, right? So forward slash some path I have given. Say for example, there are some more users in my network. If they want to install is from my local repository, they'll not be able to install it. So for that, we have to create another service and make this path part of that service. For example, HTTP service. So you have seen this previous example, right? So here base URL or mirror list is provided from a location which is part of a HTTP service. Similarly, you can use an FTP service or an NFS service. All the difference is whatever configuration which is there with respect to the service, you do the configuration first, and the same path which we have created slash repo slash red hat, you need to make this path as a part of that service, or create a path which is already under that service. Say for example, HTTP service by default, when we install it, its files are present under var www location. Okay, so create a folder under var www, and then automatically HTTP will identify that location. So identifying that location is important, since here the local path is something that is that can be easily identified. That means the system can easily move to that. But with respect to services, you need to install the service properly. Then only those folders are accessible. Okay. Similarly, the same concept is for FTP service and any other service. So when we configure those services, you will have an understanding on how to make those folders accessible. Okay. Then if you want, you can remove this path. First finish your testing and the process I have told you. Then you can go for, after we complete those services, then you can try the same using those services. I hope you are clear with this concept, right? So you
Sir,
need to do yum clean all.
I have a question here. See, if I want to, I'm directly using internet option to update my all packages. But while updating, I want to just skip certain packages. I don't want them to update through the internet. So how can I skip the specific packages? Is there any way we can mention in the somewhere in repos or somewhere? How can I skip the specific packages to avoid update from the internet?
Uh, it is possible. that option is present. Well, first of all, that is possible. You can choose what packages to install and what to not. I don't exactly remember the argument. So we install the packages using M only. So we need to provide some additional argument to M to skip those packages. I will check that and let you know in the next session for sure.
I
But it is possible.
Yeah, I think there is exclude. I have seen on the screen just now. Iphone exclude and package. Will that work?
Okay. Yeah, that's something like that. Okay. Yeah, perfect. So that's the one. Hyphen exclude equal to package.
Okay.
Okay, now we'll go through some of the commands used in order to monitor the processes and other resources in our system. Okay, these commands basically help you to check parameters like the disk usage, okay, and what is the RAM consumption, what is the load on the system, what processes are running in the system. All this information can be observed using these commands. So the first command is PS command, okay, which will provide process information. So I have added some arguments to it so that we can get all the information that we need. So I used ps-eaf, or you can simply begin with ps-ef. So these are all the processes. So here if you look at the fields present, user ID, that means this process has been run with this user, okay, by this user, or this process is run by the name of this user. Every process will have a unique process ID, okay, so that is this. So if you want to kill the process, in Windows you open Task Manager, you look for a process that is currently stuck and you click on what is it, end now, something like that. Similarly, in a Linux system, if some process is stuck, or if you want to kill some process, if you want to stop that process, you have to use a command called kill, and the kill command must be issued along with the process ID. You have to say kill space, give the corresponding process ID of that process. If you want to stop the process, this particular process, check what is the process ID, kill space process ID will kill the process. That is how we stop processes. And in this output, so what else you need? This is the parent process ID. So some processes, they fork other processes. That means like creating children of the other processes. Remember the init process that I have mentioned in the beginning. Here you can see an init process is called as the grandparent of all the processes present in a Linux system. It triggers all the other processes. So that's why the process ID is one for init process. Okay, like that. So every process will have a parent process ID. So this is the PS command. You can also cross-check all these processes using another command called as top, TOP. So even top, what it does is it will continuously provide, that means refresh uh, the information. it will always provide the latest updated information for you. Using PS command, you would only get information about the there's top command. As you can see on my screen, it has some screen refresh rate of 2 seconds or something. It continuously refreshes and it will tell you the memory consumption, CPU consumption of that process. Not only that, it provides the process ID, the user information, and there are a lot of other things here, like what is the system memory, how many CPUs are there, what is the CPU consumption, okay, and this is your uptime, how long is your system up and running, how many users are connected to the system, what is the average load on the system. So it's almost zero. There are three numbers over there. One is average load average in the last 1 minute, in the last 5 minutes, in the last 15 minutes. Like that, we have three numbers present. We make use of this information in order to monitor the load on the system. So this information can be generated using multiple commands. You can give the command called uptime. Okay, you can give free command itself will give information about system memory. So total memory, used memory, free memory, and then cached or the buffers in the system. So this is present in the form of this output is in bytes. You can say kilobytes, MB, gigs. Okay, well, mostly the preferred way is M hyphen T will give you total. So if you compare both, this line is because of hyphen T argument. Okay, so this is about your memory information.
Sir, on the top command, is that sorting by memory used?
No, it seems it is based on the CPU consumption. Well,
Okay,
the
got it.
default could be
That's what I said.
CPU, but if you want, you can change it.
Looks like CPU.
Yeah. So I was showing disk usage. So your hard disk has a lot of partitions. So all the partitions and the corresponding usage, how much is used, how much is available, okay, and what is the mount point, that information is available using the df command. Now other than df, there is another command called disk usage. So what disk usage will tell you is, I did /star. So on the topmost first level, okay, under / we have all the folders, right? You can quickly check what is the uh, space that has been occupied. So how much of disk has been used for that particular folder. Say for example, you have got an alarm that the disk has reached to 95%. You need to free some space, otherwise it would completely be filled, and you are not aware of which folder has occupied a lot of space. Then you can use this command. So here you can see, so folder wise, the top at a top level, it is giving information. So I have something like, okay, OPT has 3.7 gigs. Rest of the folders are in KBs, MB, and there is a swap file. So this is a swap that we have created during installation. So other than this, we only have OPT directory. So what I do, I go to OPT. OPT again can have multiple folders. Okay, so simply do du-sh star. Okay, so MongoDB, there is one folder called that. So you check. Okay, there are 3 more folders. I want to know the space of each. So I have identified that there is a data folder that has 3.4. So now I have to go to inside this folder and check for the files that are important, which are not, and then delete the files accordingly. Okay, so this is how you can make use of the du command. So S is to generate information, H is to provide it in a human readable form. Similarly, so among this list we have, okay, there is something called PS tree. So this is called as a process tree. So previously I mentioned init as the grandparent of all the processes, right? So init will generate these processes in your system. Similarly, I have a command called tree that using which you can check the entire file system structure. So from / all the directories and subdirectories. No, no, pwd. Let me do this. So wherever you are present from here. So I am at this location, right? pwd. So it is giving me the subfolder tree structure. So under OPT MongoDB, we identified there are 3 folders. Bin has these files. Data has these files. Again logs has these files. Now if I go to / and run tree, so this is your entire file system. All the files which are present in your Linux system. Everything will be displayed to you. Okay, then
Before you typed in PS3, right?
yeah, that is process tree. This is file system tree.
Oh, okay. Okay. That shows like a dependent process on a single process or like child process.
Yeah. So how entire processes have started. First is init has triggered some other, and then they have created some more child processes.
Got it. Okay, makes sense. Makes sense.
So rest of the commands here are vmstat. It is about virtual memory statistics. So I'll get to that later. And there are some commands using which we can run the processes in the foreground. That means, so when I run something, okay, take the same example, tree. If I run it, it will take at least some 15 to 30 seconds to display the entire file system tree. Okay, say, so in my prompt, if I run a process which is going to take more than 10 minutes, I have to wait until it gets completed. So rather than waiting, I can put that process in the background. So this process, I cannot stop even. So as altogether you have 8,000 plus directories, 55,000 files. Actually, if I run something using ampersand like this, okay, so it will run that particular process in the background. Maybe it didn't work for this particular tree command, but I can show you other commands. take for example ls-l ampersand. Oh my god, this is not an right example. Okay, okay. I'll give a better example. Okay, like yeah. Okay, I got some suggestion. Perfect. Top space ampersand. So top, as it continuously runs on your screen, so you cannot run anything else. So if you have such processes which you just want to run and live like that, you can run them, and you can cross check using the command called jobs. Okay, it will so the top is already stopped, so you can cross check like that. Similarly, there is a command called fg. So fg will pull the background jobs back to the foreground if you want. Okay, so mostly when uh, you're running processes that are going to take longer. For example, I'm going to run a database specific process, a server process. I prefer to put it in the background because I want that process to be running all the time so that I can connect to it using the clients and do my job. So there are a lot of use cases where using ampersand you can put the job in the background. And the kill command, as I've said, kill has mainly two use cases, using kill space process ID. Another one is kill space -9 space process ID. So kill process ID usually kills the process, but in case if there are any dependencies, if the process is stuck and it is not responding even to kill command, then we use kill -9. That means forcefully killing that process. So if you use only kill, you might want to double check whether the process got killed or not, but kill -9 will kill the process for sure. Okay, so this is pretty much about the monitoring tools. So there are other tools as well, but as and when the requirement comes, I will explain those tools for you. Okay, so with this we will wind up the session for today. So if you have any additional questions for me, then I'm available for you. You can ask me your queries. Otherwise, we can wind up the session for the day. All right, everyone. See you in tomorrow's class. Thank you so much for attending the session. Please try to practice all these commands and attend